Okay, so now for problem number 33 is just like 29 and just like 31. It is f of x is equal to 2 cosine of x plus sine of x. And what we're asked to write, we're asked to write this in the form of f of x is equal to a times sine of x, or sine of open parentheses, b, another open parentheses, x minus h. And I suppose probably off to the side we should probably write down what these things mean. So A is the amplitude, or just amp. B is, so we would write, this is the, B is equal to 2 pi divided by the period. And H is equal to what we call the phase shift, or you could just put PS. And this is actually from 4.4, and it's located on page 389. And so basically what we're going to do is we have 4.6 is about composite functions. So I have composite functions of trig functions. So I have a cosine function and a sine function, and they're together. I'm adding the two. And so that's a composition of two separate functions. But because they have the same periodic behavior, in other words, there's a 1 in front of this x and there's a 1 in front of this x, and normally sine of x has a period of 2 pi, cosine of x has a period of 2 pi, so these are going to kind of grow and shrink together in a way that it's what we call a sinusoid. And a sinusoid just means that it looks like a sine wave. So that means since this whole thing here will look and behave like a sine wave, I could take this whole equation and rewrite it in this form of a sine of b times the quantity x minus h, where a is the amplitude, b is the relationship between 2 pi over the period, and then h is the phase shift, or horizontal translation, sometimes you could call it. But that's technically not right because we multiply it by b, so phase shift is a better word. So the first step in this process is that we're going to have to go in and we're going to have to graph the function. So it was 2 cosine, let me clear all this out, 2 cosine of x, was that plus or minus? Plus sine of x. So we have plus sine of x. Okay. And I'm going to hit graph. We're going to look at it real quick to see what it's doing. And so, yeah, because they both grow at the same rate, it kind of looks like a sine function. You'll notice little ridges here, and there's little bumps and stuff, and that's part of the behavior. But from a distance, it looks like a sine wave. In fact, since we have to write it as a sine wave, let's just plug in sine wave so you can see how it's different. So the red graph is going to be the actual sine of x, untransformed, untranslated, just not, this is the parent function. And then the blue line, what we want to do is our goal is to make that red line match up perfectly with the blue line. The first step in that process is to find the amplitude, because A is the amplitude, right? So the amplitude is the max or min. So I'm going to hit second trace, and I'm going to find the maximum value of any one of these blue peaks. So I go a little bit to the left of the peak, I go a little bit to the right of the peak, and I go to the center of the peak, and then I guess, and then I'll let the calculator tell me, hey, it looks like I have a maximum of 2.236. Now I think this is about the x-axis. In other words, if I were to find the minimum, I think that it would be negative 2.236. I could just do that real quick to verify, but that's what it looks like. So I'm going to hit 3 minimum, and And I'm going to move around here till I get closer to the what we call the trough or the valley. Though I walk through the valley of sine, I shall fear no minimization or maximization applications. That's a really smart math joke, which is probably why nobody's laughing. So anyways, it's a negative 2.236, right? So I feel pretty comfortable in saying that my amplitude is 2.236. So what I'm going to do here is I'm going to say 2.236 times sine of x. And I'm taking some extra steps, but what I want you to see is how we're going to start with that red function sine of x and change the a and the b and the h and make that red line go right on top of that blue line. So by changing the amplitude, notice now my red curve is the same height and depth as the blue curve. Now in all honesty, this is kind of too easy. I need to find the period. Now the period looks like it's 2 pi. Now I say that because that the red line is sine of something. And sine of something has a period of 2 pi. And it looks like if I just shift this red line over a little bit, I'll be in good shape. But let's see. I need to make the red line look like the blue line. The next step in that process is to determine what h is, which is the phase shift, and what b is. Now, I have to find the phase shift in order to find the period. So let's write some stuff down here on this screen. A is equal to 2.236. Let's write down let's write down period is equal to and put x sub 2 minus x sub 1. And then h is equal to, and we'll just leave that blank for now. Actually put h is equal to x sub 1 and then put an equal sign. And we'll leave it blank. Okay. So now what we're going to do is let's fill in some of these blanks. So what I do is I say, all right, here's my blue line. Where's the first 0? Well, I look for the one that's closest to it. The red line is sine of x. The blue line is my composite function of 2 cosine of x plus sine of x. It looks like I've shifted over to the left a little bit to this line here. So I'm going to find this 0. So the way that I do that is I hit second trace, and I'm going to hit 2 for 0, and I'm just going to go a little bit to the right. Now, or to the left. Now, the truth is I could go to the left, or I could go to the right. Okay? I'm going to go, let's just go to the right. I'll go to the right. It doesn't really matter. So my left bound means I need to be a little bit to the left of the x-axis. My right bound means I need to be a little bit to the right of the x-axis. And guess means I need to be in the middle somewhere. So at 2.23, that's my 0. Now this is what we would call the shift. Okay? This is the shift. Now I'm going to put 2.03. Let's write this down on the board here. That's really x sub 1 is the 2.03. In other words, if I look at my graph, if I took this, actually, wait, let me think that through. It's not 2.03. Well, because I'm starting at this point here, and I want to make sure that we're going up. What's the blue line doing right there? Going down. So we should have done it where I originally wanted to. Well,
so it does matter.
It does matter, sort of. So now I kind of need to go all the way over here to the next one. It doesn't matter, but they do have to be going the same direction. Do you guys understand what I'm saying when I say that?
So you can't use the one on the left side?
You can use one on the left side, but I prefer to use one on the right. So I'm going to use the first one that's going up.
Oh, so you just have to use one that's going up.
Yeah. Probably, well, let's use the one on the left side just so you guys see. When we use the one on the left side, we got to think about minus and plus and stuff like that, which is easy. You could just change the sign.
So 2.03
That's
is not
wrong.
x1.
Right.
Yeah, it's not. We'll have to change that in a second. So what we're going to do, a little bit to the left, a little bit to the right, somewhere in the middle. and we'll hit enter, and we've got negative 1.1, let's just call it 1.11. And so what I'm going to do now is I'm going to come in here, and I'm going to change this. I'm going to erase the 2.03, and I'm going to put negative 1.11. But we move it to the left, so that negative might be a positive when we're done with the final formula. Does that make sense to you guys? Okay. So now over here, this is where it gets confusing. We're going to plug that in here in just a second. But what I'm going to do is I'm going to continue. I'm going to do this. I'm going to pretend that I'm a student. I'm going to do it in a way that you guys would normally do it. So what I'm going to do is I'm going to hit trace calc, or I mean second trace, which is the calculate menu. I'm going to choose the next 0. Now I'm going to go down one valley and up one peak, and I want to figure out what this 0 is. It doesn't matter. I could go in the other direction. It doesn't really matter. So a little bit to the left, a little bit to the right. Find the center. And that's negative 7.39. So let's write that down. So for x sub 2, so right under the period put equals, was it negative 7 point, what did I say it was? 39. And then x sub 1 is equal to,
Negative 1.11.
yeah, so let's put negative right here. Let's put period equals negative 7.39 minus 1.11. And so when you minus a minus, it becomes a plus. Now, I can tell you that when we subtract those, what do we get?
We're gonna get 6 point.
We're going to get a negative 6.28, which is really what?
2 pi.
2 pi. Now, it's a negative 2 pi, but that's because we measured in the negative direction. So what do we know about our period?
It's pi.
Well, it's 2 pi. Now, we went through all that work, and I could see where it get confusing, but why do we need the period? We need it because we gotta find out what b is. So b is 2 pi divided by the period.
2, 1, 2 pi.
So what's b?
1,
So b is equal to 2 pi divided by 2 pi,
which is 1.
which is just 1. All right, whew, that was a lot of work. So I'm going to come in here, and I'm going to go down to my second function, and now I'm going to try to start to graph it on the way they want us to. So they want us to put the b term, which we now know is 1, times the quantity x minus h. But we said h was negative 1.11, so what do I put in here? Let's try plus 1, 1, because when you minus a minus, it becomes a plus. I could be wrong. Okay, but we're going to see. If I was wrong, what would I change?
The negative.
I'd change to negative, right? So let's see. Now, why would somebody go through all that work if you had one equation and then you're taking a second equation to look like the composite? Computer programming. Computer programming.
Is the answer to a question?
No.
What's the question?
The answer to the question is this second graph, right? So let's write that down on the board, and then we'll talk about the application of it. So we have A, we have B. So way down here, we're going to put f of x, or put g of x,
Why is it g of x?
because it's a different function,
Oh.
is equal to A, but we say 2.236 times sine of, in parentheses, open parentheses, 1, open parentheses, x plus 1.11. And these are all decimal approximations.
Why do we need the 1 before the x plus 1 one?
Just so it looks like this formula up here.
Oh.
Yeah, would it graph the same without it? Absolutely, it would be fine. But I did it so that way when you go to do your homework, like if you were to redo 29 or 33, you would go through this process of finding out what B is and knowing to plug B in here where 1 is. Okay. Any questions on that?